Welcome to Cruz Learning, where it's just that easy, with your favorite host, Professor Cruz. And today we're going to talk about absolute value equations. So let's get started. This is our first class. This is for A1. So here we go. Let's keep it positive. Absolute value is the distance, and it's always positive from zero on the number line. So think about when you're talking about absolute value of a number line. Let's say that I have 0 in the middle, right? And let's say I have the number 4 over here. So 1, 2, 3, and I get to 4. I could do the same thing going backwards from 0, 1, 2, 3, and I get to negative 4. So the question that the absolute value answers, I should say, is how many units am I away from 0? Well, my distance from 0, if I start moving to the right, I need to move 4 units to the right. If I move to the left, I still need to move 4 units. It's just that I'm moving to the left. Okay? So this right here allows me to say the following. And mathematically speaking, when I write this down, I can say that the absolute value, I notice the symbol that I use for absolute value is 2 bars, equals 4. Okay? So if you had no graph, and I tell you, hey, x, the absolute value of x equals 4, what are the possible numbers? What are the possible x values that could give me 4 for an absolute value? Whereas there's 2 of them, right? It could be that x equals positive 4, because I move 4 units to the right, or it could also be that x equals negative 4, because I counted from negative 4 when I move to the left. So this gives us the conclusion that the absolute value of negative 4, and notice that that's not a 1, that's the absolute value, it equals positive 4. So the absolute value of any negative number always equals a positive number. This is great because it helps us to solve equations. So here we go. How to solve absolute value equations, which is what A.1 is all about. So number one, you need to isolate the absolute value. And here it is, the symbol. Remember, the absolute value symbol. And then the second step is to solve for the variable. So let's look at example 1. Example 1 is a really good example because it will explain these yellow things that I wrote at the bottom when I said solve for the variable. This is what we just talked about. The absolute value of u, let's say that u is an expression, any expression, like x plus 5 in example 1, okay, equals a. So a is 19 in example 1. If that's true, then I could set that expression equal to a, and that expression equal to its opposite. So I could say that x plus 5, right? I could say that x plus 5 equals 19, okay? Or I could also say that x plus 5 equals the opposite, negative 19. And this is the process that I call drop the bars. You can drop the bars when the variables that are inside the expression that's inside of the absolute value, it's by itself, meaning the absolute value is isolated. There's nothing being added, multiplied, or subtracted to the absolute value outside of the bars, right? So when that happens, I could drop the bars. And I think about, imagine that this is in jail, and that's when I'm going to drop the bars. When people get out of jail, you either have the choice to become a good citizen or the total opposite, negative, all right? So just remember, every time you drop the bars, when it's positive, the other one's negative. And now I do what I learned what to do when I was solving one-step equations. I use inverse operations because x is being added by 5. I'm going to subtract 5 from both sides. And that gives me that 19 minus 5 is 14. So that's my first answer, okay? And over here, x is being added by 5, so I'm going to subtract by 5 on both sides. And now I get that negative 19 is being subtracted by 5, so that will be negative 24. And those are my two answers that I get from solving the absolute value. I hope that makes sense. That was example 1. Let's do example 2. Example 2 deals with fractions. Remember that this is a video, so you could pause, rewind at any time if you need additional support, okay? All right, so here we go. You have that x, the absolute value of x over 4 equals 20. So again, I drop the bars, and when I drop the bars, one it's positive, the other one it's negative. So I could say x over 4 equals 20, just like my problem, and then I rewrite the same problem, x over 4, but then I set it equal to negative 20, the opposite. And then I solved one at a time. On the left side, x is not by itself because it's being divided by 4, so I'm going to do the inverse operation, which is multiply by 4 on both sides. These 4's cancel, and you get that x equals 80 because 20 times 4 is 80, and that will be my answer. You could also think about 2 times 4, and that gives you 8, and then you add the 0, however it makes you easier or happy. And then you get that on the right side, I multiply by 4 as well, but this time is going to be negative 80. So this time it turned around that the answer was the same number, but it's opposite, right? Now be careful because that's not always true. Remember when we did example 1, one was 14, but the other answer was negative 24, not negative 14. So be very, very careful. You need to solve these two problems completely separate. Okay, completely separate. All right, let's do example 3 because example 3 looks fun. All right, it's a fraction. And to be honest, a lot of people don't like fractions. So what would you do when you have fractions, right? Well, all you got to do is cancel the fraction. Just do the steps that you know what to do. So the first step here, hopefully you can see, it will be to drop the bars because there's nothing around the bars. And don't worry, I'll give you an example in a second with things when you can't just drop the bars in the first step. But here we can, so all we got to do is rewrite the problem. All divided by 6, and this equals positive 11. And I'm going to rewrite everything again inside of the absolute value. Okay, but I'm going to set it to the opposite, to the negative of that. Okay, and now I can solve it, right? So on the left side, what can I do to solve for that variable? We'll cancel the fraction. And the way that we cancel fractions is multiplying by the denominator. So I want to cancel that 6. So I multiply both sides by 6. Now be careful. Don't distribute the 6 to the numerator in the fraction, to the top of the fraction. You don't want to do that because the whole reason that you're multiplying times 6 is to cancel the 6. All right, so I get a two-step equation when I do that. And this is perfect because hopefully you remember how to solve a two-step equation. You just move whatever number doesn't have a variable first. You cancel that one first, and you get 2x equals 66 minus 4. Minus 2 is 64. Okay. All you got to do is move, divide. And now you divide because x is being multiplied by 2, right? Every time you have a number in front of a variable, remember, that means multiplication. So you want to use the inverse operation, which is division. And then I'm going to divide by 2 on both that number by 2, take half of it, and you get that x equals 32. A cool trick that sometimes works is that if they're even numbers, you just do that. 4 divided by 2, 2, and 6 divided by 2, 3. All right. We're going to do the same thing, same steps on the right side because I found one, but I need to find both of them. Whoa, easy there. All right, here we go. So this times 6 and times 6. And then I'm going to get 2x plus 2, very similar to the other problem. The 6 will cancel, and I'm going to get negative 66 this time. So my answer is going to slightly change. By slightly, I mean it's going to change a lot. But it's not going to be that bad. Oh, I shouldn't, let me, minus 2 here and minus 2 here. There you go. So I can actually do this step. And then the 2's will cancel. So the reason why I'm subtracting 2 is because that's the inverse operation of adding 2. And these will cancel. And I always do that with the number that doesn't have the variable, right? But I have to make sure that it's on the same side of the equal sign. Remember, x is not by itself. It's being multiplied by 2 and added by this 2. So I have to subtract that 2 first. And then my last step will be to divide 2 on both sides. And once I do that, my friends, x is by itself, and I get negative 34. Negative 34. So pretty close numbers, but completely opposites, right? When it's positive, one's going to be negative. All right, let's finish this strong. Example 4. We only have 3 examples more. This is going to be a little bit quicker now. Now, this problem, I cannot just drop the bar. I cannot just write down that expression equals positive 13 and that expression equals negative 13 because the absolute value is not isolated. Isolated means by itself, right? So to be able to get it by itself, I'm going to have to add by 4 on both sides because the entire absolute value expression is being subtracted by 4. So I'm going to get that the absolute value of x plus 5 equals 17. Now the absolute value expression is by itself on the left side of the equal sign, so I can drop the bars. And by dropping the bars, you know what I mean? I take whatever it's in there, I set it to its positive, so to itself, and to its opposite, which is negative 17. And here I subtract 5 on both sides because it's adding by 5, so I use the inverse operation. And I get that x equals 12. Okay, over here I do the same thing, subtract 5 from both sides, but my answer slightly changes because same sign, add and keep. They're both the same sign, so I'm gonna keep and I'm gonna add them. I'm gonna keep the sign, that's negative, I'm gonna add them. 17 plus 5 is 22. Just very important, some people think that this was gonna be positive 22 because they're the same sign, and at some point they heard that two negatives equal to positive. Well, that's true, but that's true for multiplication, not for addition and subtraction. All right, example 5. If I have this, again, the absolute value is not by itself. So my first step here will be to subtract 15 so that I could isolate the absolute value. And then it looks like I'm not going to have enough space to complete the problem because this is going to be 3 minus 15 is negative 12, right? It's going to be negative 12. But I did this on purpose because what happens is I cannot drop the bars here. I have an expression that it's telling me that whatever is inside of that absolute value equals a negative number. And that is not true. There's no way you could get negative in an absolute value because by definition, an absolute value is positive. Therefore, my statement that says right over here that this is no solution. So if math teaches us anything, is that every problem has an answer, even if that answer is no solution. I also put D and E because sometimes when you're doing tests or quizzes, you might see D and E, which means does not exist. So it does not exist. And it doesn't exist because an absolute value cannot be negative, okay? Let's do the last example. Are you ready for the last example? Hopefully this will help you do every single problem in the homework. What happens if I have two different absolute values on both sides? Well, it doesn't matter. We'll still do the same steps. It looks like on the left, everything is being isolated, so I could drop the bars. So I have 5x, right? 5x plus 4 equals the positive of whatever is on that side. So right now, whatever is on that side is x plus 18. But now I got to be careful, right? Because I'm going to rewrite 5x plus 4, but then I'm going to rewrite the negative of whatever's on the right side. Now, my expression on the right is a binomial because it has two terms, and that's called a binomial. So you have to be very careful. Don't just put a negative in front of the x. Make sure that you put a parentheses in front. A negative, and then you write down your expression in parentheses because at the end, we're going to have to do an extra step. Hopefully you know what that extra step is before I get there. All right, now I have to move all the variables to the left on the left expression. So let's solve the left expression. I have 1x. Remember, where you don't see a number in front of the variable, the coefficient is 1. So I subtract 1x from both sides. This cancel, and I get that 5 minus 1 is just 4x plus 4 equals 18. This looks very similar to the other problems. I'm going to subtract 4 from both sides. And if I subtract 4 from both sides, this is going to give me 14. And then I'm going to have to divide here. Let me actually do the division process. I'm going to have to divide here by 4 on both sides. This will cancel, and I get that x equals whatever 14 divided by 4 is. Well, actually, I can reduce this fraction as 7 over 2 because I could divide top and bottom by 2, right? These numbers are divisible by 2. So it's very important, and if you can reduce a fraction, you do it. Because when you enter answers in your homework and your tests, they're going to expect the simplified version, the reduced version, okay? If not, if you put 14 over 4, they'll mark it wrong. Let's do the last problem. The last problem, you will have to distribute a negative sign. So make sure that you distribute it. This is going to be 5x plus 4. This does not changes. And this equals negative x minus 18. Okay. And then you move all the variables to the left. So you're going to end up with, let's actually do it, plus x over here and plus x over here. And I'm going to subtract 4 from both sides. When I do that, this x cancels. I get 5x plus x is just 6x. And then plus 4 minus 4 cancels. And that's going to equal negative 18 minus 4 is negative 22. My last step to get x by itself is to divide both sides by 6. And when I do that, I get that x equals. Now again, I can simplify this. Hopefully you can see these are both divisible by 2. So this is just negative 11 over 3. I hope that this helps you on solving equations with absolute value. This was Professor Cruz, and it's just that easy.